Hello everyone. So today we are going to see the fluidized bed combustion boiler or FBC boilers. So today we are going to see the introduction, working principle, types and advantages of the FBC boiler. Okay. So FBC is nothing but fluidized bed combustion. So this is the introduction. Okay. So whatever the major portion which are available, the major portion of the coal which is available in India, it is having a low quality, high ash content and low calorific value. So due to that, what happens? The traditional great fuel firing system has got the limitations, and they are techno-economically unviable to meet the challenges of the future. So that's why this FBC, that is fluidized bed combustion, has emerged, which is a viable alternative and has a significant advantages over conventional firing system. And apart from that, it offers multiple benefits of having compact boiler size, fuel flexibility, higher combustion efficiency. Okay. Also, whatever also the fuel which can be burned in these boilers, which can be included as a coal, wash rejects, rice husk, bagasse, and other agricultural wastes. And these FBC boilers have a capacity range is having from 0.5 ton per hour to 100 ton per hour. Okay, so now let us see next the mechanism or the principle. Okay, so here let us see the working. When an evenly distributed air or gas is passed upward, okay, upward through a finely divided bed of solid particles. Here you can see the grate is there, and above the solid particles are distributed on this bed. Okay, so when an evenly distributed gas or air passed upward through a finely divided bed of solid particles such as sand supported on fine mesh, the particles are undistributed, okay, undistributed at the low velocity. Okay, as air velocity is gradually increased, a stage is reached when the individual particles are suspended in the air. Okay, in the airstream, the bed is called fluidized. Okay, as the air velocity is increased gradually, a stage is reached that the particles are suspended in the airstream. The bed is called as a fluidized. With further increase in air velocity, there is a bubble formation. Okay, vigorous turbulence, rapid mixing and formation of dense defined bed surface. The bed of solid particle exhibits the properties of a boiling liquid and assumes the appearance of fluid, that is a bubbling fluidized bed. Okay, so here the bubbling fluidized bed is there. Okay, at higher velocity, bubble disappears and particles are blown out of the bed. Therefore, some amount of particles have to be recirculated to maintain a stable system. Okay, so after bubble formation, what happens? Initially, the solid particles are there. So when the air is supplied into the furnace, it got undistributed. Okay, and further increase in the air, okay, increase in the air velocity, stage is reached that the individual particles are suspended in the air stream. Okay, and further increase in the air velocity, at this time there is a formation of a turbulence in over here. Okay, and here the bubbling of fluidized bed occurs. Okay, and at further higher velocity this bubble disappears and particles are blown away out of the bed. Okay, therefore some amounts of particle have to be recirculated to maintain a stable system. Okay, this is called a circulating fluidized bed. Okay. Now next we are going to see the types of FBC. So first type is atmospheric classic fluidized bed combustion system. Second is atmospheric circulating fluidized bed combustion system. Third one is a pressurized fluidized bed combustion system, that is AFBC, CFBC and PFBC. Okay. So in AFBC, a coal is crushed to a size of 1 to 10 mm, which is depending on the rank of a coal, type of fuel feed and feed into the combustion chamber. So about this we will see just brief information. Okay. So let us see directly the fuel feeding system in this AFBC boiler. So here you can see the bed is there. Okay, and here the nozzle is there. Okay, this is underbed feeding and this is overbed feeding. You can see. See, if for feeding the fuel like limestone or dolomite, usually two methods are allowed: underbed pneumatic feeding and overbed feeding. Okay, so first let us see the underbed pneumatic feeding. If the fuel is coal, it is crushed to 1 to 6 mm size and pneumatically transported from feed hopper to the combustor through a feed pipe by piercing the distributor. Okay. So based on the capacity of the boiler, the number of feed points is increased as it is necessary to distribute the fuel into the bed uniformly. In an FBC boiler, coal feeder height may be increased above the bed level to reduce the primary air fan power consumption and also to reduce choking of coal feeding pipe by bed material during starting of the boiler. So this is what the underbed pneumatic feeding. Now next is about overbed feeding. In this, the crushed coal, which is having 6 to 10 mm size, is conveyed from coal bunker to a spreader by screw conveyor, and the spreader distributes the coal over the surface of the bed uniformly. Okay. This type of fuel feeding system accepts oversized fuel and eliminates the transport lines when compared to underbed feeding system. Okay. Okay, as it has various feeding systems are there in FBC boiler, like fuel feeding system, air distributor, bed and in-bed heat transfer surface, ash handling system. Okay, and in further ash handling system there are further components are there, that is bottom ash removal, fly ash removal, electrostatic precipitator. Okay, and the next type is circulating fluidized bed combustion, that is CFBC. Okay, so just we'll see the brief about this CFBC. Okay, this CFBC has involved a conventional bubbling bed combustion as a means to overcome some of the drawbacks which are associated with the conventional bubbling bed combustion. Okay, and the next classification is a pressurized fluid bed combustion. Okay, this is what the FBC boiler for cogeneration, that means it is used for the generation of the electricity over here. Okay, so it is a variation of the PFBC, that is pressurized fluid bed combustion, is a variation of fluid bed technology that is meant for large scale coal burning application. In PFBC, the bed vessel is operated at pressure up to 16 kg per centimeter square. Okay, this system can be used for cogeneration or combined cycle power generation by combining the gas and steam turbine. Okay, so in this way the electricity is generated more efficiently than in conventional system. Okay, and the overall conversion efficiency is higher by 5 to 8%. Okay, so this is what the PFBC. Okay, now let us see the advantages. Okay, so first, that is high efficiency. Okay, so the FBC boilers can burn fuel with a combustion efficiency of over 95% irrespective of ash content. FBC boilers can operate with overall efficiency of 84% plus or minus 2%. Okay, so this is having a high efficiency. Second, reduction in boiler size. So high heat transfer rate over a small heat transfer area immersed in the bed, so it results in overall size reduction of the boiler. Okay, next, fuel flexibility. So the FBC boilers can be operated efficiently with variety of fuels. Okay, even fuel like flotation slimes, washer rejects, agro waste can be burned efficiently. These can be fed either independently or in combustion with coal into the same furnace. Okay, so there is a fuel flexibility. Next, that is ability to burn low grade fuel. So the FBC boilers, it gives the rated output even with inferior quality fuel. The boilers can fire coals with ash content as high as 62% and having calorific value as low as 2500 kilocalorie per kg. Even carbon content of only 1% by weight can sustain the fluidized bed combustion. Okay, so it has the ability to burn low grade fuel. Next, that is the ability to burn fines also. Okay, that means the coal contains fines, okay, which is having a below 6 mm, can be burnt efficiently in a BC boiler, which is very difficult to achieve in conventional firing system. Okay, next, that is pollution control. So the SO2 formation, that is sulfur dioxide formation, can be greatly minimized by addition of limestone or dolomite for high sulfur coals. Okay, so 3% limestone is required for every 1% sulfur in the coal feed. So low combustion temperature eliminates nitrogen oxides formation. Okay, so there is a pollution control. Next, that is low erosion and corrosion resistance. So the erosion and corrosion effects are less. Why? Due to lower combustion temperature, softness of ash, and low particle velocity. Okay, which is having about 1 meter per second. Okay, and the next advantages are that easy ash removal. Okay, that is, since the temperature of the furnace is in the range of 750 to 900 degrees Celsius in FBC boilers, even coal of low ash fusion temperature can be burnt in the boiler, and ash removal is easier as the ash flows like liquid from the combustion chambers. Hence, less manpower is required for ash handling. Okay, next, that is simple operation and quick startup. As high turbulence of the bed facilitates quick startup and shutdown. Okay, so full automation of startup and operation using reliable equipment is possible. Next, fast response to load fluctuation. That is, inherent high thermal storage characteristics can easily absorb fluctuation in fuel feed rates. Okay, so the response to changing load is comparable to that of oil-fired boilers. Okay, so it is having a fast response to load fluctuation. Okay, and next, that is provision of automatic coal and ash handling systems. So the automatic system for coal and ash handling can be incorporated, that is making the plant easy to operate comparable to oil or gas fired installation. Okay, so the automatic system can be incorporated in this system, okay, compared to conventional fire system. Provision of automatic ignition system. Okay, so the control system using microprocessors and automatic ignition equipment use excellent control with minimum manual supervision. Okay, and next point, that is the high reliability. So the absence of moving parts in the combustion zone results in high degree of reliability and obviously the low maintenance cost. Next, that is the reduced maintenance. So the routine overhauls are infrequent and high efficiency, and it is maintained for the long period. That's why it is having a reduced maintenance, quick response to changing demand. Okay, fluidized bed combustion can respond to changing heat demands more easily than stoker fired system. So this makes it very suitable for applications such as thermal fluid heaters, which require rapid responses. And the last point, that is the high efficiency of power generation. By operating the fluidized bed at elevated pressure, it can be used to generate hot pressurized gases to power a gas turbine. This can be combined with a conventional steam turbine to improve the efficiency of electric generation, and it gives a potential fuel saving of at least 4%. Okay, so in such a way, today we have seen the FBC boiler mechanism, advantages, okay, types. So today we are going to